On the western edge of northern Saskatchewan's prolific Athabasca Basin lies the Patterson Uranium District, home to the largest uranium finds of this century. The corridor stretches through Fission Uranium's PLS project, NexGen's Rook 1 project, and the Hook Lake joint venture owned by Purepoint Uranium, Cameco Corp, and Orano, Canada. Over the last 10 years, hundreds of millions of dollars have been spent in the discovery and advancement of a handful of deposits, which include resources in excess of 300 million pounds of uranium. The Patterson corridor, however, stretches far beyond these known deposits and carries with it the potential for similar finds. By analyzing the common elements of the known mineralization, a model can be established, providing a roadmap as exploration heads north. Drawing focus to this region was the unusually large number of graphitic conductors running in parallel bundles from southwest to northeast. These are typically the initial target indicators for uranium exploration in the Athabasca Basin. A close look at these conductors, however, reveals a different source and setting than those seen on the other side of the province. Taking a closer look at where these conductors came from, it is most likely that they began as deep, long-lived parallel faults in hard, competent rock, in this case as granitic gneiss and diorite gneiss. After a great deal of time, the upper portion was eroded away, creating a deep bowl-like depression across the province, resulting in what we know as the Athabasca Basin. This depression slowly filled with sandstone, leveling off the basin. Continued movement of the underlying basement rock extended the existing faults up into the newer sandstone. It is at this point that the stage is set for a mineralization event. Unlike the eastern conductors, the graphite here appears to have worked its way up from depth along these faults. As hot uranium-bearing fluids pushed between the faults, the granite and diorite was altered into chlorite, hematite, and clay. The intense heat also left extensive silicification along the hanging wall, seen here in yellow on the right. Where the opportunities presented themselves, uranium formed as deposits along the edges of the graphitic faults. Finally, glacial movement across the area deposited a layer of soil and rock known as overburden on the sandstone. We can now see how this model fits by comparing it to known deposits. Looking at Fission's RRR deposit, we see the familiar graphitic conductors bounding the green altered rock. Beyond the conductors, we see the silicification left by the intense heat of the mineralization event. The RRR sits just outside of the basin, so there's no sandstone cover. The original sandstone was most likely removed by the glaciers that moved across the region. By comparing the model to NexGen's Arrow deposit, we once again see the parallel conductors containing the altered rock and nearby diorite. However, we also see that faults take on a much more vertical stance. This speaks to the significant depth of the deposit. Finally, we compare the model to Purepoint's Spitfire deposit. Again, tight parallel graphitic conductors, significant altered granite and diorite, and the mineralization lying along the upper hanging wall. Beyond Spitfire is another 14 kilometers of the Patterson Trend, with the most recent discovery to the north in the Sabre Zone. With hole 105, Purepoint tapped back into the familiar model, and this past season carried out an additional geophysical survey to the north in order to identify follow-up drill targets. Hole 105, seen on the left, not only presented a host of parallel conductors, but as well significant alteration in the form of chlorite, hematite, clay, and intense alteration. Further, radioactivity was registered throughout the hole as seen here. There's been but one hole drilled between 105 and the northernmost claim line of the property, an area in which you could fit 9 discoveries the width of NexGen's Arrow deposit. A more fulsome examination of the Sabre Zone will be presented in part 2. In the meantime, we continue to sift through the mountain of data directing us to the next great find in the Patterson Uranium District.